if I could ask Glenn, Matt and John to come to the stage as well. Earlier this morning, George, when he kicked this session off, talked about the work that Professor Robin King did. And I had the privilege of working with Robin at University of South Australia. And I want to acknowledge the great contribution that Robin has made to the profession over many, many years. It was a great privilege to work with Robin. But I learnt from that time that you never, ever took a phone call from Robin, because as sure as eggs, he was going to ask you to do something. And he twisted my arm to lead and have the honour of leading the review of engineering education for the Australian engineering schools, all 35 of them that exist in this country. My definition of engineering really comes from the work of the Royal Academy in the UK. And I really love their definition that engineering is making things that work and making things work better. And I think that's a very good definition, and one that's been exhibited through the sessions that we've had already. As I've already said, I had the honour and privilege of leading what I think is the third review of engineering education since outcomes-based education, the first being led by Professor John Simmons in the 1990s, the second by Robin King himself, and then mine. We completed our work in 2021 and is entitled Engineering 2035. We looked ahead that far because we recognise we are steering a battleship and not a speedboat. It does take time to turn engineering curriculum around. All the reports, and there are 4 of them, are available on the Australian Council of Engineering Deans website. There are 4 parts to the review. What does industry want? What curriculum can deliver that outcome? Do we have the engineering academic staff with appropriate skills and experience to deliver that outcome? That's a whole topic for many days, and I don't intend to talk to that today, but it is a major piece. And then finally, how can we market that outcome to both potential students so they understand the curriculum that they'll be exposed to and the learning experiences within that curriculum, and finally what they're trying to do post-graduation. While today we've talked about the potential crisis in terms of the leaky pipeline or the pipeline not being large enough, it's my contention that the quality of education at University of the Australian Engineering Cohort is anything but in crisis. It has served this nation extraordinarily well. We should be very proud of the engineering students we graduate from the Australian universities. That does not mean that it doesn't need to change. It certainly does, but that is change that is incremental rather than complete overhaul. So we went to industry and we asked, what is it you want from a modern engineer? Now we've heard all that today, and I'm not going to rehearse that, but one thing that did come out, which has not been said today, is that the way engineers think is fundamental. And whatever else we might do, we want to make sure that we train engineers in engineering thinking. And that must remain inviolate. All the other things about disciplines, the role of disciplines, emergent disciplines, new career pathways, all of that can happen. But we must maintain the training and education of the way engineers think. And it's different. It is different from other disciplines. And that's what is inviolate. So we could talk about changed nature of work and complexity and team solving, problem finding as well as problem solving, working in teams, more communication skills, all of that. Let's set that aside. We all know that. We then said, well, what's the curriculum that can deliver that? The first thing to note is that Australian engineering schools are large. Australian universities are large. We have very large universities in this country. Monash University, my alma mater, takes in over 1,000 engineering students. These are big schools on a global scale. So while we could identify areas of good practice, often it is the case that there's one enthusiastic academic staff member working with 40 to 100 students, doing something very creative, doing something very good, but it's really not scalable. So we went looking for scalable solutions, and there are a considerable number of examples that we could point to that are available to implement in this country. All of them involved more experiential learning. They involve first-year engineering practice as well as engineering theory. They involve streams throughout the 4 years that continually build on and scaffold the learning in experiential learning. They introduce more engineering practice than perhaps we have done in the past. What's happened so far? Well, Engineers Australia, through their accreditation process, is seeing, through the accreditation documentation that's coming through for accreditation, reference of the Engineering 2035 report, reporting to Engineers Australia how the curriculum has changed as a result of that report. I couldn't be more pleased that it's not sitting on a shelf, that is actually changing practice. Engineers Australia have committed to, and I'm looking at Bernie here, has committed to help produce examples of best practice and share those best practice throughout our 35 engineering schools. The engineering deans have stumped up money, some $250,000, to create the Engineering Futures Institute, which will benchmark practice across the schools, collect examples of good practice as well, but also create a first-year engineering project that can be used in the engineering schools across Australia in the way that Engineering Without Borders has done so successfully already. What I wanted to focus on before I sit down and shut up and allow the speakers to talk is the changing nature of how we actually promote that. And I want to point to this picture, which we've seen throughout the day. And I don't want to insult whoever I think put together that picture. I know they would have spent a lot of hard work probably finding that image. But firstly, if I had done what those girls are doing when I was an engineer in ICI, I would have created a mass walkout. You touch the tools on an engineering site, you've got a strike on your hand. Secondly, engineers don't do that. That's not what engineering is about. It's not the reflection of modern engineering practice, nor is high-vis and hard hat the only way to promote engineering. So if you feel like I'm being provocative, I am deliberately trying to be so, but I think that's one of our problems. We don't promote what engineers do in real-world practice. The report that we had commissioned by a very well-known marketing firm told us that we don't tailor our messages to the committed, to those who are considering, to those who are capable, to those who are wavering, to those who are mature age and have done a VET program. And we don't really market to the influencers. We have a long way to go to improve the way we promote engineering and the brand that we don't create about what engineers do. I'm reminded that 20th century lifespan increased by 35 years. A little bit of that's medicine, but most of it is due to better drinking water, better waste disposal, and improved housing, none of which involves medicine. Where are we promoting the role that engineering plays in the development of solutions to our problems which are well known to all of us in this room? Where are human-centred outcomes? Where are the people-to-people interactions? Where are the multidisciplinary teams being illustrated? Is engineering really then the liberal arts degree of the 21st century? So I'll leave you with those thoughts and I was going to ask Matt to speak first.
Is that okay? Okay. So I'd just like to say thank you so much for the invitation and how glad I am to make this connection. My name's Matt Bauer. I'm the chair of the Australian Technologies Teacher Education Network. So that's an official network of the Australian Council of Deans of Education. So all the initial teacher education programs in Australia have people who are responsible for teaching technologies and STEM. And we are the most represented and strongest network of the Australian Council of Deans of Education. And we have at least one representative in every university across Australia. And our mission is to try and improve STEM and technologies teacher education and conduct the research that makes that education work as well as possible. And we struggle to engage the way we would like to with industry, with engineers, to achieve our goals. So I'm hoping that in talking to you today, that this might forge some connections that make a real difference and be part of the solution. Just a bit of background to some of the things that I'll be saying. So this graph is, and if you haven't checked it out yet, the Australian Institute of Teaching and School Leadership has a wonderful repository of Australian teacher workforce data. And one thing you may notice in this graph is amongst the proportion of out-of-field teachers who are teaching design and technologies down the bottom, it's highest for that group. So basically what's happening is we've got less dedicated and trained technologies teachers in classrooms teaching the engineering, STEM, technology subjects that we would hope that we would have trained teachers to do. Technology and STEM is a really challenging area. It's different to, I used to be a mathematics high school teacher for several years after starting a career in actuarial. So when we're talking about transfer and moving around, I've lived that, not from engineering. I was so tempted. I got a scholarship to study actuarial studies, and we might start to talk about that towards the end of my talk. It's really challenging because unlike mathematics or some other areas, it's, I would say, the fastest changing field. There's a whole lot of tactile and physical resources that you need to take responsibility for and manage in the classroom. You often become like the tech support go fix it person within schools. There are a wide range of different courses to teach. Peter touched on that. I see it as an Apple problem that Steve Jobs fixed when he sort of said, look, we've got so many different technologies courses. We've only got a few thousand people in each. We need to really consolidate that. And that's why we have specialists, so few specialist teachers in all of the different technologies areas or technologies and applied studies areas, is because they're so wide. I think in New South Wales, for instance, there's about between 12 and 15 technology and applied studies courses, and that doesn't include some of the more TAFE-oriented courses. And we've got skills in such high demand that anyone who's worth their salt could easily go out into industry the next day and earn double. The curriculum is sometimes diluted by other areas. Peter spoke about this a little bit. For instance, in the New South Wales years 7 and 8 curriculum, half of it is agriculture, the other half is food technology, which an out-of-field teacher can very easily supplant any sort of more problem-solving and analytical technology-based work with, okay, let's just sort of talk about things to do with agriculture and food. And so you've lost that opportunity to inspire people about the STEM area. It's also really challenging for teacher educators because I'm not sure if you're aware, and you know, we have a lot of additional responsibilities beyond just training teachers. We're actually often promoted more on the research that we do instead of the training of teachers and the teaching. We've got a lot of service demand. Interestingly though, we'll come back to this later, our service component can be externally facing. So a lot of the service that teacher educators do in the technologies area is working with schools, for instance, by conducting professional learning. Schools of education, we heard a little bit about this from Mark Scott in his panel. They're severely under-resourced, and so we can't do a lot of the things that we would like to be doing. And we compete in the curriculum, and Peter's graph once again, talking about all of the different areas that a primary school teacher, for instance, has to teach. Science and technology is between 6 and 10% of that. And I'd like to sort of also point out that that's science and technology. A lot of teachers don't teach that in integrated ways, which means for the technology part, it's like ends up being 1% of what you get to really focus in on as part of initial teacher education with all of the other things. And I'm not saying that any of these other things like food and music and literacy and art aren't important. What I'm saying is we really need someone to step in, and I think the people here are great people to advocate for this and say we need more time in the curriculum to dedicate to this because this is of national importance. This shows the aging workforce. This is old data. My anecdotal suspicion is that over the last sort of 5 years, it's got worse. And you can see that you would expect in any pipeline due to attrition that you would have a downward slope. Instead, we've got this upward slope. And you can see what that's going to mean for our science, technology, mathematics teachers. So it really is a pipeline issue. I'd also like to propose, though, that maybe a pipeline isn't the best analogy we could draw here. I actually like to think of it as a cycle, because we've got to understand what's coming out one end needs to feed back into the other end. So what we've got at the moment is undertrained, under-supported school teachers who just aren't capable and supported and prepared to provide the teaching experience that we would hope for students in schools. So there are fewer students choosing technology and STEM subjects, less people studying technology and STEM at university, and then less technology and STEM specialists who are deciding, hey, I really enjoyed that, I'm going to go back and I want to be a teacher. So we really need to think in terms of ecosystems, in terms of cultures, in terms of cycles, so that we can have well-trained and supported teachers with an optimal experience for school students. And we've heard today from a lot of people, I think there's consensus, this starts early to then have people choose technology in schools, study it at university, and be so inspired as to want to go back and do that in schools and teach in schools. So in terms of addressing the problem, here are some recommendations from the Design and Technology Teachers Association based on, and it's a little bit old now, but it's the best we have from 2019, which talks about, if you want to look it up, the chronic shortages of teachers. They recommend upskilling of existing teachers through professional development courses, industry-supported national technologies and STEM teacher recruitment, subsidisation of initial teacher education, increased starting salaries for candidates who retrain from industry. And I'd like to pick up on that a little bit further on the next slide. Improved and consistent STEM initial teacher education, and making sure that the people who do choose to pursue this role aren't subsumed into other areas of the school that further add to their burnout. So just to sort of be a little bit provocative, some additional from today solutions that I think, you know, if we're really serious about this, then as a nation we should be considering is scholarships for those talented engineers to pursue teaching. Wouldn't it be great if engineers thought, you know, one really viable and important and valued and pathway for an engineer is to go back into teaching, and they know that they're going to be valued commensurately in terms of their salary, etc. through that pay. Support professional teaching associations. There is actually, and I really appreciate the points that Michael's making. We don't have to reinvent the wheel here. There's amazing work going on. The problem is that teachers are so overloaded that they don't get a good chance to do the professional learning that they need and get the resources that they would like. And for instance, the New South Wales ICT Educators Association, they basically do their annual conference on the weekend because they can't get time off school. They're often paying for themselves. Where really, given the contribution that those people make, you would hope, and you only get under those circumstances the very best and most keen, you would hope that they would be supported in some way to financially and with time in order to do that very important professional learning. Engineers Australia could, for instance, coordinate subsidies for school teaching programs and sponsoring teachers. What a magnificent organisation to say, okay, we're going to do this at a national level. So we're going to approach industry, Telstra, NAB, whoever it is, to come up with subsidies to get people into teaching and support teachers. What about service requirements for engineers? A lot of professions have those requirements where you either have to do a certain amount of training to keep your registration up to date and/or service back into the community. A national program where we get engineers into schools and inspiring young students about that as a career pathway. Packages and training that helps engineers engage with schools. So if you are an engineer, what do you do? How do you go into a school and make sure what you're doing is successful? So is there some sort of way we can develop up a rapid start toolkit along with some strategies for how to engage and motivate students? Michael, I think your work would obviously be critical there. Adopting a contemporary system approach to teaching STEM. Mark Scott talking about, why are we using that old paradigm of one teacher in every classroom trying to work in isolation to reproduce everything and learn everything for themselves? If we have the best teachers and we know who those best teachers around the state and country are, why aren't we beaming those people into classrooms in remote and regional areas, and also using as an opportunity to upskill those teachers in those remote locations so that they understand what great teaching in STEM is all about, and then they can start to assume more responsibility while working with their students. So in summary, we need more qualified STEM teachers in the education system, more qualified teachers coming into the system, more support for those out-of-field teachers, more flexible training and teaching across the system using online technologies, and an extensive and coordinated response from government, industry and universities with these themes that people have been identifying, and I'm certainly so keen to work with you to achieve. So the way that the Australian Technologies Teacher Education Network can help is by a coordinated approach to improving STEM teacher education, conducting the educational research. So we are a team of sort of almost 90 researchers in universities who can provide the evidence on what great pedagogy is, and also to validate a lot of the programs that that people have been talking about in an independent and also calibrated way. It's all very well to say students learnt. It'd be a travesty if you'd put all that effort in and they hadn't. What we need to understand is what are the most effective ways and high impact ways to teach and have students learn in STEM. Really want to work with industry and government, advocate for change. We need your support, raising awareness about A10 and this organisation, and I know that I'm probably right at the end of my time, but think of the point of amplification. These are the people who teach the teachers, who teach the students about technology and STEM. And if we can make a difference there, we can really make a difference across the entire field. Would love to collaborate with you. My name's Matt Bauer, so and you can easily look me up at Macquarie University. And we're also at the moment looking for sponsorship to do simple things that universities don't have the money for at the moment, like bring people together, all of those 90 people, for professional learning that could involve working with Engineers Australia or any other organisation to give our teacher educators the skills and resources they need. So I'll sign off there.
Glenn.
Hello folks, everyone can hear me okay? Excellent. For those who don't know me, and many here probably won't, my name's Glenn Fay. I lead the education program at the Centre for Independent Studies. We're an independent public policy think tank based here in Sydney. We really work at the intersection, at least in my program, between education and research. That is what the studies of how children learn, what is impactful pedagogy. So we work with teachers as well in the teaching community around what practices are most likely to be effective. We work in policy and bridge policy and practice gaps, and we also contribute to public policy and public commentary and engagement on issues facing the education sector and the like. And it's good to be in a forum where possibly I'm not known for my public commentary as much. So it's good to be here and to be talking to you. When I had a similar conversation sharing some of our research to the Mathematical Sciences Institute a year or so ago, I thought it was really novel to be saying that the solutions all start in primary school, but it turns out that's kind of been echoed through most of today. So what I'll do is I'm only, in this presentation, I'm just going to underline some of the things that I think can add a little bit to what's already been emphasised at a great deal already through the course of today. And to emphasise that I will also be focusing here on observations and implications, particularly around math education, because it's the area that our research has been looking into in the most depth. And we mostly here are looking at the engineering challenges that have been talked about at length today as math education and math outcomes challenges, rather than the particular lens around engineering that you've all talked about. So I'll briefly sort of summarise what I'm here to talk to you about in terms of symptoms, causes, and potential solutions. And I'll mostly tease those out and hopefully have the chance to talk to that a little bit more through the discussion. As I mentioned, that's mostly here I'm talking about math school education. What I'll highlight as the first part of that distribution is the low performing tail. Now, in Australia, we have around 10% of students in Year 4 who are in an achievement level that's considered to be very low and not reaching an international benchmark. There's a much greater proportion of those students in Australia than you see in most Asian countries, as you can see here, where it's about 1% in many of those systems. But it's also there's a lot more students in that low achieving category than compared to other English-speaking school systems as well. So it's one that we should be quite awake to on that end of the distribution. I'll also highlight this improvement that you see in a similar system to ours, which is England, where back in 1995, 18% of students were in this low achieving category, and then that's reduced to just 4% at the last international survey of data that looked at this. And the reason I've got some confidence in this number too is that you may have captured last week, NAPLAN results were released, and there were some new benchmarks introduced in this year's testing, and around 10% of Australian students are achieving at a level that's considered to be needing additional support, and that these are students who are well below year level expectations, and that basically aligns with what international surveys have told us about benchmarking. So we've got reason to believe there's some confidence in that. Across the board, numeracy outcomes have basically been stagnant. What I'm showing you here are the amount of months that students are sitting in 2022 compared to when NAPLAN first started. So by way of expressing that, in reading in Year 3, students in 2022 were 9.5 months ahead of where students in 2008, when NAPLAN was first introduced, ahead in their early reading skills. In numeracy, it's a bit over a month, so a couple of weeks worth of progress improvement. Over 15 years, it's a pretty limited return on investment in terms of overall results in the system. It matters because the this is just correlations between the level of maths that students do in year 11 and 12 and their achievement at different levels in numeracy in NAPLAN. NAPLAN does tell us what students are most likely to do, higher levels of maths, basically. We've probably talked at considerable length here about the declining level of enrollments in higher levels of maths and intermediate and higher levels of maths over a relatively long period of time. You can basically track declining achievement in the PISA student assessment, an international test of 15-year-olds. It's considered to be the most challenging benchmark that we have. On this, Australian students, I'm afraid to say, have been declining in their average level of achievement in maths at the fastest rate in the developed world. So that is a very real decline, and it is one that we've seen over 20 years. Why that matters to us, particularly in this room around engineers, is that I'll draw attention to the bottom line here. That's that the students who enroll in higher levels of maths in year 11 and 12, four out of five of them come from the top quintile of PISA achievement. So if we have fewer students achieving that highest level of achievement, that's where we directly see the impact, particularly in the engineering pipeline. I mentioned I'm going to move past a range of things. We can talk to these at some point, but I suspect they've more or less been covered through others' contributions. Let me identify a couple of red herrings that I see. Students in Australia don't have disproportionately bad attitudes or confidence or interest in maths. We are basically at the international average on that. We don't have a structural problem in Australia about interest levels in maths. We do have an achievement problem though. And a result that might surprise you in the latest NAPLAN results just last week show that other than year 5, there's no statistical difference in the achievement level between girls and boys in NAPLAN numeracy. That is, at year 3, year 7 and year 9, there's now no longer any statistical difference in outcomes. Now, some version of this has been presented virtually every time today, so I won't rehash the kind of change motion, if you like, but basically it's a process about capabilities within school, and I'll really emphasize and underline that. Big part of that comes down to practices. So Mark Scott, who was here in the morning, talked about the work that he's led in the teacher education expert panel. They came down very heavily in the way that teacher training programs do need to align better with the science of how children learn. And that science of learning and science of teaching needs to be better reflected in the way that teachers are prepared. In some of the markers of that, this is just an illustration of what students report in the PISA assessment and the frequency in which they experience compared to a high-performing country like China. Quite ready indicators of whether children are likely to be successful in class, whether there's clear demonstrations, whether teachers check for understanding, whether they provide a previous review of learning, and so on. These are very good markers, and when children report on those, it's a very good indicator of what teachers' practice is really looking like and is ultimately a source of truth in some of these. Some of our research has highlighted what we see as being where best evidence about teaching practice lies. Again, I won't speak to length in this forum, but it's one that we talk within teacher forums about a lot. The things that we identified in our paper here, that's from 2021. This has basically been endorsed through the Australian Education Research Organisation's work. That's helped to define what tried and tested teaching practices look like. It also mirrors a lot of what you see in the What Works Clearinghouse work on effective maths teaching, particularly for struggling learners over in the US. So we've got a degree of confidence in what we've identified there as well. A lot of discussion today about the number of maths teachers and the capacity of that workforce. I'll highlight here that see that 16% on the Australia column. That's the proportion of primary school teachers that have a maths background, if you like, qualification level. Compared to Singapore, that's 2/3. So in primary school, maths backgrounds are very much lacking. And that's even half the international average. And the international average is fairly soft in that we should generally perform better than the average in many ways. I'm going to move past that one because it's the same thing more or less. Matt touched on out-of-field teaching and presented some data from the Australian Teacher Workforce Data base, which I'll disagree is a good source of data. It's got a lot of problems in it that we're working on, but it will one day be a very good source of data. One thing that's promising to see is that across the categories we're most interested in here, technology, maths and science, the last couple of years has seen a significant improvement in the rates of in-field teaching. And I realize those colours are probably not labelled correctly, but the green is your in-field. But there has been some improvement in the last few years, so that's some good news on the horizon there. The other good news is that a lot of people want to become teachers, including maths teachers. The government's review found that 4 in 10 mid-career professionals. Now this includes professions that are STEM related, and it did look at that specifically. But 4 in 10 mid-career professionals want to become teachers. Teaching still has a very good rep among adult populations, but we do have a lot of barriers to enter, and those barriers are especially true for those holding STEM-related backgrounds, which I'll highlight in a second. I'm also going to underline here, this is the months of the month level equivalent of learning for students in Year 3, based on whether they could, in pink, or could not, in blue, do each of these tasks at the age of 4 or 5. So what you can see is that children in Year 3 are about a year behind, or close to a year behind, if they fail in the task of sorting and classifying at the age of 4 or 5, and if they're struggling in a number recognition task at the age of 4 or 5. And I won't spend more time on that than to point that out. So possible solutions, and I'll just tease these here, and perhaps we'll speak to them at some more length through the course of the discussion. We've talked about the skills of the teacher workforce. That's size, strength, and skill, basically. On the size front, some of the things we can try that have worked in other countries. Instead of using financial incentives to get people to do a teaching degree, give them financial incentives to do a STEM-related teaching degree for starters, but also withhold some of that money for when they actually take a teaching job. Because in the past, a lot of these initiatives have pushed someone through the pipeline, but they've just not necessarily become a teacher. So you need to withhold some of that benefit for when they actually enter the teaching workforce. There's also people in this room may be aware that Southern Cross University just introduced an out-of-field teaching bridging course, if you like, a relatively short course. That's the sort of thing I think is really valuable for those in the profession who are out of field, and some persistently out of field, getting some bridging understanding about how they already know how to be an effective teacher, but how to be an effective math teacher. That sort of course would be very valuable. As far as mid-careers, one of the structural problems here is that changing one line in the industrial agreements, for instance, could recognise prior experience and prior learning. And if we could recognise prior experience and prior learning, we wouldn't require all new entrants to teaching at whatever age or experience level they come with, having to start at the same salary base. And of course, that's an unattractive offer for many of the target group that we look to. Also, just as far as being provocative, I'll throw a provocative one out there that certainly teacher audiences don't like, and that's that salaries in secondary teaching in particular could be based on field of study, not just everyone working, because you work in a school, everyone earns the same. I know that's provocative, but it is one that, in my view, is we do have to tackle if we're ever going to address that fundamental problem. Teaching practices, I mentioned that there's greater alignment or greater knowledge now about what effective teaching practices look like. There's still a lack of supply of practitioners that can help to build that community of practice, but it is a work in progress. The teacher training review and work has been a very important step in doing that. And the final one is really focus on the early intervention approach in school. There's 2 critical markers of the age of 4 and grade 4. The age of 4, we can tell a lot about children who are likely to do well in maths by whether they're graduating out of finger counting to mental number line representations. And we can tell a lot about the success of being what we call cardinal principle knowers. That is, they understand magnitudes and numerical values in that fashion. I won't go to any more length on that. And when we talk about year 4, some of the key critical predictors are around fluency in math facts, particularly things like even boring stuff like times tables. And also that one of the key markers is success in fraction magnitude equivalence tasks, because of the combination of many different elements there when it comes to mathematical cognition. But I'll leave that there and pass on to our next speaker. Thanks very much.
My slides, John Phillips. Yep. Okay, good. Okay, it's been a long day. Last talk before we hand over to the people that are going to tell you the conclusions. So enough of the hand wringing, enough of the gnashing of teeth. I'm going to provide solutions, at least what I regard as solutions, across 4 categories. This is what Dr. Alice Bunn, Chief Executive of the UK's Institution of Mechanical Engineers, in late 22 replied when she was asked in a TV interview what specific STEM skills need to be developed further. I needn't have bothered. I think we've heard from previous speakers, the industry speakers, absolutely. This is the sort of stuff we need to be in our curricula, to inspire kids, for teachers to actually inspire kids with projects. Yet, this is the current draft of the mandatory technology syllabus that's being proposed for the kids, our kids, or grandkids, in New South Wales. Yes, it's project-based, it's experiential, thumbs up, but the focus of these projects is what you see there. The content of the production and engineering processes focus area is about enabling students to develop knowledge, understanding, and skills in the use of materials. There's nothing there about clean energy, and nothing at all to convince a young person that learning to be an engineer could help save the planet. This syllabus and the ones for primary, Science and Technology K-6, are actually in review right now. The closing date for public feedback for this one has just closed. The Science and Technology is for K-6 is, I think, in September. But let's not look at the public side. We're not public. We're an engineering community that really wants to make sure that our curriculum should reflect the world challenges in technology. So I believe that we, or more particularly Engineers Australia, ATSE, should get their heads together and put a joint submission to all education ministers in all states to say how important it is that the curriculum in our schools, particularly in this area where young minds are being made up, that it does reflect the current challenges in the technology world. And more to the point, and this is what I will expand on later, to ensure that their organization and content, as well as reflecting the current global challenges, adequately describes the role of engineers and the engineering process. We really do have to get our act together because we clearly haven't been heard to date. STEM education. That quote, or that excerpt, is from the introduction on the federal government's website to the National STEM School Education Strategy. I don't see much about engineering there, or actually technology. There is also little indication in the strategy that STEM is a concept, or a way of thinking, or that it should be considered and taught as a balanced whole, and not just an assortment of skills and disciplines shown in that slide. So, with the input of colleagues, I've put together another graphic. STEM in practice, not just STEM, S-T-E-M, science, technology, engineering, math, where it actually indicates the unique skills which these disciplines learn and how they apply them to actually achieve purposeful outcomes in the real world. In the real world, engineers don't solve problems through the prism of each individual discipline. They seek out and appreciate the contribution of all disciplines, including the humanities. That's what STEM seeks to bring to the classroom. That is what this STEM in practice slide illustrates. Put that into learning. Where do we learn all this? We have to be taught. It has to be taught. STEM without engineering is like an orchestra without a conductor. Not good. But governments are constantly exhorting us to introduce STEM in primary schools. But how can this make sense to primary teachers when all they are familiar with is technology? Also, if modern engineering was better understood in primary education, there'd be no need to add arts to the acronym and call it STEAM. Or add medicine in secondary education and call it STEM, which I've seen. Horrible. Also, talking about modern engineering, and this has been spoken about before, advertising engineers as being all hard hats and high-vis vests just does not help at all. So, we must assist teachers and in-school STEM coordinators, and yes, STEM is being taught in school. Everyone assumes they know what it is. And STEM coordinators are being tapped on the shoulder. If anyone in the school shows the slightest interest in coding, you're a STEM coordinator. But we have to teach them to understand what they're talking about. We must unpack engineering from technology as early as possible in our curricula. The problem is not in the content. You've heard this before. It's in the language. You can't be what you can't see. We also must place more educational importance on the practice of engineering, all those skills shown in the green box. Of course you've got to do the fundamentals, but it's the application, it's what Michael's saying, it's what everyone's been saying. So let's think about creating a STEM micro-credential. Let's embed it in all Bachelor of Education degree courses. We're told they're teaching it. Let's teach them what it is. And offer it to every teacher tapped on their shoulder by the principal to be a STEM coordinator. My final comment on STEM as a concept: don't dismiss it because it has failed to acknowledge engineering. Think of it as a Trojan horse, which is already happily grazing in school pastures. STEM ambassadors. 21 years ago, over 2 decades, the UK government established a company called STEM Learning, which amongst other things administers and coordinates their STEM ambassador network. Today the network has some 30,000 volunteers, and I know UK's bigger than us, but 30,000 is a big number, who collectively contributed 640,000 primary and secondary school classroom hours to schools in 2020. And here's something that I think should resonate with everyone here. Of those 30,000 volunteers, 7,500 were trained by the Institute of Mechanical Engineering. 7,500 engineers in the field in the UK. Participation by companies in the programme is considered both good for business and for education. With, for instance, Rolls-Royce. They put 1,200 in the field. Thales Group, 200, and so it goes on. STEM ambassadors in the UK do not provide professional development for teachers. That's provided by STEM Learning. Think of them as tilling the ground so that programs such as were introduced in the previous session can be accepted more readily and, extending the analogy, take root more effectively. Here in Australia, many companies and institutions run or want to run school outreach programs. But as you've heard, they operate individually and not collectively. Good examples are the programs administered by EA's indefatigable Karen Morgan. I'm calling you out here, Karen, who has done so much to make this symposium possible, and the excellent work being done by Helen Link and her team of enthusiastic engineers promoting STEM in Newcastle schools. They actually mentor the teachers that are teaching the engineering studies program and doing a very good job. You may not know, but we have a version of the UK's program in Australia. It's the federally funded STEM Professionals in Schools program, administered by the CEO and run by Julie McClemens. They employ 8 full-time equivalent staff. They have 1,024 professionals on their books, of which 420 identify themselves as engineers. But like all such programs, its management still must negotiate individually with schools to get their professionals there, and with companies to find volunteers. And one of the problems that Julie said to me, they can't find where the engineers are. Well, that might be a good place to expand from if we were to get behind, as I believe we should, a full-throated STEM ambassador scheme here in Australia. Now, personally, I'd actually probably like to see that called STEM advocate, because I think ambassador is a bit, we've got something good we're going to show you. Advocate, we've got to actually get out there and advocate, because it's a very hard job ahead of us. But STEM ambassadors at the moment, because that's what people are familiar with. Now, 2 decades ago, the UK faced the same problem of engineering invisibility that's been discussed at the symposium today. Exactly. In response, and here I think I'm coming to what a lot of the, not so much complaints, but the, we can't get through, it's got to be a brand. Well, they decided they would do something about it. They decided to treat engineering as a brand to be marketed to young people through school outreach programs by a dedicated company called Engineering UK. Engineering UK is not just another engineering lobby group. It is governed jointly by the UK's professional and chartered institutions, plus business and industry. School outreach is difficult, as anyone who has tried it will tell you. It's just not in the DNA of engineering companies and institutions. Indeed, the further up or down, depending how you want to say, the pipeline you go for education, the words, the language, it's just, we don't talk the same language as primary school teachers. Let's fund a company that will do the work for us. The important thing that the UK found was that forming such a company allowed the professional institutions to concentrate on their core business of registering engineers to keep public safe and supporting them. Engineering UK also publishes an annual engineering brand monitor, which produces these sorts of stats. They keep the business focused. They also run a Tomorrow's Engineers website promoting the wide range of careers in modern engineering, produce a State of Engineering report, and promote and underwrite the Big Bang Young Scientists and Engineers Fair. In 2022, just coming out of COVID, the fair drew over 20,000 visitors from schools across the country. This is not just a Mickey Mouse organization. This is not a bunch of volunteers. This is not just 1 or 2 people. They don't do anything unless they have 1,000 people in it coming in. This is what we should be thinking about. So, raising the awareness of engineering amongst our younger generation, their teachers, their parents, and their guardians will go a very, very long way to removing, or certainly lowering, all the other barriers that exist in the engineering supply line. So let's move on from identifying the problems upon which we can all furiously agree and seriously consider acting upon the solutions detailed in the slide. Without detracting from the impact of that last slide, let me share a personal aspiration to conclude my presentation. My grandson, and his father's actually over there, is studying ag tech in year 10. and his future career profile points him towards engineering. I've no doubt he'll become one. And if he also became a STEM ambassador, I would love him to turn up in the school car park with a sticker on the back of his car. It felt uncomfortable for an engineer of my generation, and I'm sure for most of you, to display such a sign. And my wife, whose car it is, hates it. But I said, I'm doing this symposium, just leave it there for a while. But hopefully the success of solutions born out of this symposium will make it feel natural for future generations of Australian engineers. And I'm happy to take sticker orders during this evening's network session. And finally, copies of this address plus all of his additional background papers can be found there. And in those papers, there are 5 pages of potential solutions that I put together in advance of this, but chose to just do this one. Some background on the barriers and issues, and also going into some of the what was talked about before. What is the difference between a technician, a technologist, and an engineer? So if you go there, you'll find some of this stuff, and I hope you find it useful.
For those who are watching the clock, the last session, the very last session, will be much shorter than advertised in the program. So be assured that we will get out to drinks even beforehand, before the time actually. And we do have time now for around 3 questions, if we could do that, if there are questions for the session. Oh, you lost it for the day.
Yeah, thank you for the opportunity. Mine is just a comment, not a question, in terms of promoting engineering. I agree that we don't do enough to promote. And if you ask women engineers, invariably they have a parent, a father, or a family member who's an engineer who encouraged them. For those who aren't aware, 4th March is World Engineering Day. And we reached 60 million globally this year. And the online celebration was watched by 1.5 million globally. But in addition to online, countries around the world have embraced it, and I'd love to see it more celebrations in Australia. It's not meant for engineering institutions, it's meant for the community to celebrate. So for example, in Nairobi, they had a fun run celebrating engineering, with engineers wearing t-shirts. I love being an engineer. My dad's an engineer. Engineers do good. It was phenomenal. And then it was on TV. And I think this is the sort of grassroots stuff that we need to think about to celebrate engineering and its impact.
Yes, the interview that I referred to, Dr. Alice Bunn, was done on World STEM Day last year. Absolutely agree.
Yeah, my question is, going back, and we needn't get them back on, the graphs where it showed the percentages or numbers of people, I think Australia was 14%. The UK, where you talk about these initiatives, went from, I think, also 14 to 4%. I wonder if you now eliminated out of the numbers the people. Now, my wife's not here, so but she knows I'd say this. If she sees numbers, she sees blank. You know, she's a historian, not a mathematician. So if we took her cohort out, you might find that you're down to maybe 2%. Do you normalise any of your numbers in these graphs to take out the one, just to get rid of the people that have got no interest in maths, would never do any good in maths and so on? Thank you.
Yeah, just as far as the what I've showed, I didn't do any breakdowns there on other than the recent NAPLAN results. The one thing I would point out that by about year 4, year 5, you do see for girls a significant drop-off in interest level in maths, and you do see very real experiences of math anxiety that are present in schools, and that's above and beyond. That's even after accounting for issues about sort of general anxiety, even test anxiety. There is a sort of residual math anxiety that is more keenly felt for whatever reason with girls than with boys. But boys do experience a degree of math anxiety on average more often in word-based school problems. So word-based problems, which are increasingly a feature of assessment, you do see that gap there. But yeah, there are some differences, but yeah, on the whole, same pattern overall, the same trends are there, but yes, some small differences.
Peter, I'm really interested in what you would replace that image with.
I'm not the expert in marketing. I think no, I'm actually very serious. I think we need, as a profession, to get in some serious help around what those images should be. So I'm not being flippant. I'm actually saying let's get some really good help, because that's not the right image.
On the image thing, I'll ask two of my daughters are marketers, so I'll show them the picture and see what they came up with. But look, there's been a lot of interesting ideas and some facts, and I think one of the key takeouts for me is that this is all kind of contributing to solutions, but it's all kind of disaggregated. If you had an overall policy framework, what would it look like to synthesize all these ideas and get the sort of outcomes we've been talking about? That's point number one. And point number two, who's going to volunteer to put that together in the 48 hours before we had to make a submission to Mary O'Kane's accord process?
That's what Mark is going to talk to us about in the last session. Yeah, well, yeah, but I'm up here. I'm certainly not in 48 hours. We have one last question at the back.
Thanks very much. Lots of passion here today and a lot of strategic thinkers. It's brilliant. But that's today. How do we keep our conversation going beyond today and start to turn that into some kind of action?
I think, can we just take that as a great segue and actually the last wrap up? I'm not trying to dodge it, I just think
I was just setting you up.
Well, look, on your behalf, can I thank the three speakers?